Okay, step number 4. Step number 4, I'm going to do it slightly different here. This is just terrible, terrible, terrible board technique to do, but I don't want to give an entirely new page, and it requires a little bit of writing. Step 4 is to say that the total solution, I sub L, is equal to the natural solution plus the forced solution. So here it's pretty clear. It's equal to, since the forced solution is 0, it's equal to just this. Yeah, that looks awful. I sub L is equal to e to the minus alpha t. Oh, and we already know what alpha is, right? We earlier determined that alpha is equal to 9. So e to the minus 9t times c1 cosine, and we figured out what alpha d was earlier. We said it's 4.36t plus c2 times sine of 4.36t. Okay, all we need to do now is to find out what C1 and C2 is. And we do that just like you learned in differential equations, or you will learn, by looking at these initial equations we found, the initial conditions we found back on step 1. One of the most common problems that I see cadets have is they really can't abide by the fact that they've got these unknown coefficients in their natural solution, and they want to find them first before they find their forced solution. Don't do that. Leave these coefficients in there until you can add your forced solution, which in this case is 0, so it works out to be the same. But in general, do not find your coefficients for your natural solution. These coefficients could be anything, and it will still be a match for what this circuit does for time greater than 0 for different cases of this having non-zero initial conditions. So let's move on to the solution. We need to find C1 and we need to find C2, but we know what the circuit is doing at time equals 0, and we know what the circuit is doing, what the derivative of the circuit is doing at time equals 0. So let's use that information. At time equals 0, this I sub L is got to be 1. So at time equals 0, what's this e to the minus 9t?
E to the 0.
Which is 1. So we've got this C1 here. What's cosine of 0?
1.
Okay. That's pretty easy. And then what's sine of 0?
0.
So now we know that C1 has to be equal to 1. So let's rewrite our equation. Whew. Now we're going to do the same thing, but we're going to take the derivative of it. So when we take the derivative of this guy, we know it's equal to minus 6. What's the derivative of this main thing, this huge thing? Well, you know it's the derivative of this part. I think that was the end of our lesson. I'll do it really fast. It's the derivative of this thing, which is minus 9 e to the 0 times, we'll just write this down verbatim. We don't have to take its derivative. This becomes cosine of this mess just becomes 1 plus 0. And then we're going to add to it this thing taken at 0, which is just 1 times the derivative of this. And I don't want to hold you up too much. Remember we said the derivative of sine is a positive cosine, so the derivative of this will be something minus. It'll be minus 4.36 times our sine of 0. But that is going to be 0, so we don't really need to worry about it. Plus 4.36 C2 cosine of 0, which is 1. So you get minus 6 equals minus 9 plus, from over here, 4.36 C2. And from that, you can figure out what your C2 is. It's 0.688. And so now you can figure out what your entire isabel is. It's equal to minus 9t C sub 1, which is 1, times the cosine of 4.36t plus 0.688 sine of 4.36t. And it's possible that if you had something more complicated, you'd have to solve it using matrix equations. You'd end up with 2 unknowns and 2 variables. Whew. That's our answer. Whoops, and I forgot to write that's in amps. Okay, so that's really everything to do with this entire exam block. The only things that change is that if they're in parallel, it's a different equation for what alpha is. And then we've got 3 different possibilities for what our natural solution is, depending upon which of these 3 combinations it is. Any questions on all that before I let you go?